Hey Siri, stop the alarm. All right, gentlemen, I have that it's that time, so we're going to go ahead and get started. Let me start by sharing my screen. Oops. And typically what I do for attendance, I do my attendance in waves. So you guys made it into the first wave, so you don't have to worry about it. So anybody, like, I'm pretty sure somebody's getting to the waiting room like now or whatever. I'll check attendance again at the 15-minute mark, right? So I say that to say the recommendation is you definitely want to be in my waiting room about 5 minutes before the start of class. Especially, I'm coming from another class before I meet with you all. So usually I'm probably going to be pretty punctual because I'm wrapping up my other class and, you know, I just reboot everything. Let me see. As far as announcements go, so, you know, we've had our first set of assignments due last night, but I don't want you fretting about that. Even though we had like a homework and a quiz due last night, you can still access it. There's a 10% late penalty, but that's 10% of 10%. It's a very small portion of your overall grade. And to be honest, like if we get to the end of the semester and you're like within a fraction of a point, if you're close from like one letter grade to another, I would just give you that credit for that. Like I'm going to give, like if, I'll give you credit for that assignment, provided, if you got like a 90 on that first assignment because it was late, then I would make sure that you would get those credits. But I'm not going to let something like one late homework and quiz stop you from the grade. Now, if you're making low marks on your exam, that's a different story, right? But if you're doing what you need to do, then, I'll just give you credit for that late assignment. I just don't want to do it right now, but I'm not going to let it get in your way. So again, with all assignments, we get unlimited attempts. The system is set to take our highest score, and there's an automatic extension built into all assignments. So even if you submit something late, it's okay. But then it really only becomes an issue like when it's something like an exam, because the exams are like majority of our grades. The exams count for like, I want to say 80% of our overall grade, by the end of the term or whatever. So, but, those are scheduled for release. You want to do your best you can to try to submit those promptly with as high as mark as possible. As we go through the presentation, if you have questions, feel free to unmute yourself to get my attention and we can talk about it. I'll be a little bit nice and check my attendance right now again. Let me see. Let me go ahead and get these gentlemen. Again, I usually check it a second time at the 15-minute mark, but, it's okay for right now. And I'll still check it at the 15-minute mark. Let's see if there's anything else. So we kind of touched on the homework with the automatic extension built in. It's a good idea to be subscribed to my YouTube channel with the notifications turned on. I know I had at least one student use the Ask My Instructor. I did not get a chance to reply to his inquiry, but as I start replying to you all's inquiry, I'm going to be posting my responses on my YouTube channel. So at least the main thing with that experience is you just want to be aware of the things that I'm posting. So you can be like, oh wait, I had a question about that question. I had a question about that problem. Let me watch that, or oh yeah, I know how to do that. I'm gonna just keep it moving, right? Versus everybody asking me questions about the same problem repeatedly, right? So the main thing with the notifications is just to be aware of the things that I'm posting. Sometimes I do Easter eggs, sometimes I do gameplay, just we kind of a little bit of downtime, which we don't really have a lot of. And so today, and like again, the main structure of this course is that it's remote asynchronous, meaning that majority of the learning is done on your own. Also, let me kind of finish up this idea. So I say that to say, anything that I want to say in the lecture is already available in my pre-recorded lectures on my YouTube channel, right? And so to access that, like if we go to Blackboard, let me go to our course. So if we go to Blackboard and open up our course, which is here, all right, we open up this main folder, and you can find it here at the bottom, right here, at the bottom where it says YouTube links. So if we look at that, the links that you all need is the first link and the third link. The first link is a playlist for all our lectures for the semester. So anything I want to say regarding a section, I put in that first link. The third link is a playlist for all my live sessions from this semester. So like, for instance, what you and I what we all talked about last Wednesday, you can find in that third link. What we're talking about today, you can find in that third link, so, and you can also sit in on my sessions for my other students in that third link as well. That second link is just an Easter egg. It's just basically my lectures for the next term for College Algebra 2. You don't really need that right now. The main ones you need is the first and the third. Also, another thing I want to bring to your attention on Blackboard is my math lab is going to be folder number 3 under assignments, right? So you click on this. You want to click on the first link that says all assignments. When you do that, you're going to be prompted for like payment and registration instructions. Just go ahead and register. If you've used My Math Lab before, you can register with those credentials. If you've used My Math Lab before with the same book, you shouldn't have to purchase full access again, right? We use this book for 3 different courses, but if you do have to pay for access, Right now, at the bottom of that payment screen, we encourage you all to get the 14 days of temporary access because the administrators are negotiating a price reduction for you all. So just give it, you want to get the 14 days and give it a week or two and see if we can get the price down. And so then, but once you get past the payment window, then, you know, you have your assignments with the corresponding due dates. So this first homework and quiz was already due, but again, it's just a small late penalty. You know, if it's the end of the semester and you're close, I'll just give you the credit for that. I'm not going to let that small late penalty stop you. Again, a limited attempts, the system is set to take the highest score, and there's only a 10% late penalty. Notice that we have weeks 1, 2, 3, and then it jumps to week 5. It jumps over week 4 because that's when exam 1 is scheduled to be released for 7 days before it's due. Same thing for week 8 and week 12. That's when you can anticipate the exams, okay? And then one other thing I need to bring to your attention on Blackboard. So we have our main landing page. This course has a lab component that's separate than what we're doing together. So again, we're doing our assignments in My Math Lab, which I just showed you how to access. But for the lab component on this left-hand maroon panel, you want to click on that second link that says Online Alex Lab Syllabus and Zoom. That's where you find the information for the lab that's hosted by Dr. Lamar. So you would open up the syllabus and reach out to Dr. Lamar. You basically want to follow her instructions. Sorry, I've been talking since like 9 this morning. I'm totally exhausted. Even my voice is going out. So, you know, we'll do the best that we can. But yeah, you want to contact Dr. Lamar and basically follow her instructions. And at the midterm and the final, she's going to give me a grade for each student that's in the lab. And all I'm going to do is take the grades that she gave me for the lab component, and I'm going to scale it to 10% of your overall grade. So that Alex portion, that counts as 10% of your overall grade. You just have to follow the instructions for Dr. Lamar. And then, but we are going to be using My Math Lab, right? Like we saw earlier. As always, if anything is not clear, feel free to unmute yourself to get my attention or type in the chat. I am monitoring the chat. I'm going to check my waiting room looks good. Let me see. Let me hop back over here real quick. And what I'm going to do is open it up here. I don't want to switch. I want to join. This one is correct. Nope, not that one. Done. Don't connect my audio. Yes, please do not connect my audio. Join, because it goes haywire if I do that. I want to stay as a participant. That's fine. I get it. Thank you. Got it. And you know, I just want you all to be aware that this is being live streamed to my YouTube. I know there was a question in the chat. Let me check it here. It's fine. Chat. Let's see what's going on there. I already bought the access code, but I don't see where to enter it. If you're using the temporary access, you might have to just wait it out. Like it should be like when you log in, or I'm not really sure where they have it. If you at some point, like you might have the temporary access right now, and you might just have to wait for it to run out. Then when it expires, use that access code. I'm sure you can enter it sooner than that. You have to kind of go into the settings somewhere to find where to load the access code. In the summer, and it has prompted me with a message that says digital download, high volume has was able to 4 hours in the summer. So if with that summer payment purchase, the main thing is you want to make sure it comes with an unused My Math Lab access code. You know, so that's the main thing there is you're just trying to gain access to My Math Lab. For right now, I would encourage you to go ahead and, you know, go to Blackboard, go to folder number 3 with assignments, click on that link that says My Math Lab All Assignments, and go ahead and register as a student and click on the link that says get 14 days of temporary access, right? Go ahead and use the temporary access to get started. And if you already purchased it, you have to make sure that it comes with a brand new My Math Lab access code. because that's what you need access to, is the access code, the MyMathLab access code, right? So that's the main thing, is MyMathLab. Yeah, I can't think of anything else. Otherwise, you might need to either try to get like a refund or an exchange or something of that nature. But the main thing is you need an unused MyMathLab access code. And again, for all students, I encourage you all to do the 14 days temporary access, because the administrators are negotiating a price reduction. Okay. All right. I am totally burnt. I don't really want to talk, but we need to. I want to talk about this stuff with you all. I don't want to not be available. But keep in mind that anything that you see me doing this presentation right now has already been available in my pre-recorded lectures, right? So the real intent of the structure of this is remote asynchronous, which means that most of the learning is done on your own. And idealistically, I like to use class time as like an unofficial office hours or as a Q&A. So we really could use this time to go through homework or quizzes or exams. I personally just fill it with live lectures as much as possible as a courtesy. But we generally speaking don't have enough time in our meetings to go through everything in the lecture. So that's why I made my pre-recorded lectures, okay? So hopefully that makes sense and you have what you need, okay? All right. Oh, man, I do not want to talk anymore. Like, I'm just like, okay, that's enough of that. That's not. I was checking. I think you guys are good. I don't know why I'm checking that. Okay, so again, today's presentation is a courtesy, but again, you've had access to it in my pre-recorded lectures, and we'll go through as much of it together as we can for the section 1.1. But whatever we don't do together, I do expect you to use my pre-recorded lectures. And then on Wednesday, we'll go through section 1.2, and that'll get us caught up. Generally on a weekly basis, usually what I do is like on the first day that we meet, I'll use that day as a lecture. And then on Wednesdays or the second day that we meet, I like to go through as much of the homework together. But everybody still needs to submit their own assignments, because basically it permutates the numbers. Like, it's not the same numbers for everybody. So everybody gets their own stuff, right, that you need to submit, right? So you can follow along with me just as an example, but everybody needs to submit their own stuff, okay? So we'll go through as much of section 1.1 graphs of equations together as we can. And so we have these learning objectives. We like to plot points in the Cartesian coordinate plane, find the distance between 2 points, find the midpoint of a line segment, sketch a graph by plotting points, find the intercepts of a graph, find the symmetries in a graph, and find the equation of a circle. Okay, we'll get through as many of these together as we can, and you are responsible for the rest. Any ordered pair of real numbers is a pair of real numbers in which the order is specified. So the order pair x comma y equals -3 comma 1. That means, where's my pen? So what this means is that x equals -3 and y equals 1. Right? X equals -3, y equals 1. So the ordered pair A comma B has first component A and second component B. We say that two ordered pairs are equal if and only if their corresponding components are equal, right? So the first components are equal and the second components are equal. So x equals A and y equals B. Okay, I feel like that's not too bad. So the set of ordered pairs of real numbers are identified with points on a plane called the coordinate plane or the Cartesian plane. Right, so what this plane is, we have our x-axis, where the positive x-axis is over here to the right. We have our y-axis, which is laid on top of the x-axis at a 90-degree angle. Positive y is in this direction. So then when we say the x-axis with the y-axis at 90 degrees, what it does, it breaks the flat surface, the plane, up into 4 quadrants. So quadrant 1 is going to be this upper right-hand region, right? So everything in this direction. So quadrant 1 is the upper right. And then the quadrants progress counterclockwise. So then quadrant 2 is going to be the upper left. Okay. So everything in that direction. Quadrant 3 is going to be the bottom left. What happened? Did we lose our image? I'm coming. I see it cut out. Ooh. Let's share my screen. Oh, and then I have to optimize the video. Okay, that looks good. Okay. So we talked about the quadrants. So then when we go to plot ordered pairs, generally, I mean, we start at the origin, and then the ordered pairs are basically serve as like a roadmap on where these points are located on the Cartesian plane, right? So positive x is to the right, negative x is to the left, positive y is up, negative y is down. Okay. So then we refer to the points corresponding to the ordered pair A and B as the graph of the ordered pair AB in the coordinate system. The notation P of AB designates the point P in which the coordinate points whose x coordinate is A and whose y coordinate is B, right? So that's how we label our points. Let me check Zoom really quickly. I think you guys are okay. Okay. So in this example, we're asked to graph, right? And I feel like this is fairly straightforward in that, for instance, if we're looking at the ordered pair A, which is 3, 1, so if we start at the origin, this is saying go right 3 and up 1, and that's where we would plot A. For B, this is saying go left 2 and up 4. Left 2 and up 4, there's our B. This is saying, for C, is saying go left 3 and down 4. So if we go left 3 and down 4, there's our C. So on and so on, right? So again, the ordered pair kind of serve as a roadmap. It's similar to like longitude and latitude. Longitude and latitude is the same concept. It's just if you overlay this on top of a ball or a sphere, right? That's the idea there. Okay. So then we want to introduce this idea or notion of the distance formula in the coordinate plane. And we're going to introduce this by recalling that the Pythagorean theorem states that in a right triangle with hypotenuse of length C and legs of length AB, A squared plus B squared equals C squared, right? So we have a right triangle. The legs are labeled as A and B. The hypotenuse is labeled C. Then this formula is the Pythagorean theorem. Okay. So then we want to derive, I want to do a quick derivation to show you, copy, where the distance formula comes from. So let's paste. Okay. Sure. I think I might just do a rough sketch for this one. Okay. I did a detailed sketch in my previous class, but I think that was overkill. All right. So say we have the positive x axis in this direction and our positive y in this direction, right? Say here we have the points P. We're going to label it as x1, y1. I don't know why this thing is lagging. And here we're going to have the point Q. We're going to label it as x2, y2. Okay. And we're going to connect it with a straight edge, right? So if we want to find the distance between P and Q, how could we do this, right? So this here corresponds to our x1. Here corresponds to our x2. Here corresponds to our y1, and here corresponds to our y2, right? So x1 is this. Come on. X2 is there, y1, and y2 is here. Okay? This image should look familiar. I think we just talked about it, right? So if we wanted to find the distance between 2 points, well, we can relate this discussion to a right triangle, right? So in the previous slide, if we let this be A on top, let this B be over here, and C is our hypotenuse. I'm going to shrink this down to give myself some space. Okay. So the Pythagorean theorem we had was what? A squared plus B squared equals C squared. I'm not sure why my device is lagging. It might be because I have it plugged in. I'm going to unplug it for right now. Okay, so then suppose we want to find A. Well, A is that segment, the horizontal segment, so it's here. A runs from x1 to x2. So if we want that distance, we can capture that by saying x2 minus x1. So A is going to be x2 minus x1. And we want the positive, undo. Right? And we want the positive distance, so we're going to take the absolute value, right? If we go ahead and incorporate that into the Pythagorean theorem, then that component is going to be squared. That's our A. So then for B basically runs from here to here, which corresponds to y2 and y1, right? So then B, we can say is going to be, that's fine. I don't want to do audio recording. It's going to be what? Y2 minus y1. We want the positive distance and incorporate it into the Pythagorean theorem because it's squared, right? Same concept as the first part. And then C is our distance between P and Q. And we're going to square that distance. So if we want to solve for the distance between P and Q, we take the square root on both sides. So then the distance between P and Q is going to be the square root. Now usually when we do square root, we usually do plus or minus. But because we're doing a distance, we only want the positive distance, right? So typically, again, whenever we introduce the square root, we're supposed to do plus or minus. But in this context, because we're doing the distance, which has to be positive, we're just going to take the positive result. And then if we take, so absolute value is a positive number, but if we square a positive number or a non-negative, it remains positive or non-negative, right? So in other words, the squared nullifies the absolute value, so then we can rewrite it as x2 minus x1 squared plus y2 minus y1. Oop, I don't know why I always do that. Quantity squared. Okay. And that's where the distance formula comes from on the next slide. Right? So given 2 points P and Q, be any 2 points in the coordinate plane, then the distance between P and Q, denoted by d of PQ, is given by this distance formula, right? So let me take this as an opportunity. So hopefully you all are able to be like neat and organized. That's going to be the main challenge with this course, and honestly with the whole college experience, is a lot of it is centered around your ability to organize information, and have good time management, right? So that's part of the reason why I went on and made all assignments available for the semester, with the exception of the exams. So that way, anybody that wanted to get ahead has that opportunity. They can watch my pre-recorded lectures, and they can get ahead. And honestly, if you wanted, you could finish all assignments for the semester, and then you'll just be waiting on the exams and making sure to get your attendance credit, right? And then that way, when we reach the midterm and finals, you're not like you're reducing your stress level, because that's going to be one less thing you're going to have to worry about. You're going to be expected to be submitting projects in all classes, preparing for other exams and things of that nature. So if you can go ahead and get my stuff out of the way, there's one less thing you got to worry about, and you'll be positioned for success. So then with that organization, with that being neat and organized and time management, hopefully you all have a homework notebook. You have a notebook where you're being neat and organized, where you have a copy of the lecture notes. Again, anything that you see me writing, I'm going to make it available that you can access on Box via Blackboard and that second folder or whatever, the second link. So you'll get a copy of anything that you see me writing. So in your notebook, you definitely want to have some version of the lecture notes. Also in your notebook, you want to have a copy of your homework, right? So any homework that you're doing, idealistically, you have a copy of the original question. You fill in any supporting details on like how to solve that or how it should look. And then you put your final answer in a box, or you highlight it with a bar with a double slash like I did, right? So in your notebook, you have the lecture notes, your homework, and then I brought it up is because of this. Hopefully in your notebook, you can incorporate a formula sheet, right? So every time we come across a formula, we update our formula sheet with that, right? So I know we talked about the Pythagorean theorem, a squared plus b squared equals c squared. You definitely want to include that on the formula sheet. This distance formula you want to put on the formula sheet, right? And so that way, as you practice and study, you'll be like, well, let me see, does this fit one of these formulas? And you can jump to your formula sheet, do a quick scan, versus if you haven't been doing anything or taking notes or being organized with no intent, then you're kind of wasting your time. Because even though right now we're not in a testing environment, like right now our tests are kind of scheduled on your own, that doesn't mean that it's not going to come to time when you are going to be responsible for this material in a testing environment. I had some students last semester where they were required to do their final exam in a testing environment. Like they had to come to campus, something of that nature, and do a in-person final exam, right? So, you have a little bit of a cushion. The recommendation is to do your own work, but you can collaborate with people. I'm okay with that. Just you want to do the best to process as much of this as you can, because if you just shirk all of it or shirk too much of it, it's gonna come back to bite you at the most inopportune time, right? So we're just trying to position ourselves for success. Again, if anything is not clear, feel free to unmute yourself to ask questions and we can talk about it. Or type it in the chat. I am monitoring the chat. So here's a digital representation of what we drew on that previous slide, but the concept is the same with the explanation that we gave. Okay. So here we have an example of finding the distance between 2 points. We're actually finding the distance between the points P and Q, right? So one of my mentors would say every time we use a formula, he would encourage us to write it down. So the formula here is going to be the distance formula. So the distance between P and Q is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Right? Also, what I like to do whenever I'm given like a set of ordered pairs, I like to just label them as x1, y1, and x2, y2. And so, again, when it comes to these examples, I pretty much, in my pre-recorded lectures, I'm saying it's presented essentially the same way. I just gave myself time to touch on those concepts towards the end of each section that we just don't have time for in our live sessions, right? We're just not going to have time. So that's why I defer you to my pre-recorded lectures. Okay, so let's see this in action. So basically we want to substitute the corresponding components. And my recommendation is when we're doing our substitution is to start by replacing each component with a blank set of parentheses, right? So what I mean by that, the distance between P and Q is going to be the square root of x2 minus x1 quantity squared. Let me clean it up just a little bit. Plus y2 minus y1 quantity squared. Right? So what I did, I replaced each component with a blank set of parentheses. Now when I go to do my substitutions, the blank parentheses help us to keep track of our signs. So we're less likely to make a mistake with our signs, right? So our x2 is 3. Our x1 is -2, right? So there's something going on with the signs there. Our y2 is -4, and our y1 is 5. Okay, so notice that, you know, our blank parentheses help us to keep track. Oh, we got a double negative going on here, right? Without our parentheses, it's easy to miss that double negative, and then from there on, it would be wrong, right? If we miss that sign, it would be wrong, right? Okay, so the double negative becomes positive. So then 3 plus 2, that becomes 5 squared, plus -4 minus 5 is -9 squared. Okay. Sorry. So then, let me see. That's going to be 25 plus 81. And that's going to be the square root of 106. And then if you want a decimal approximation, you would just use your calculator. Okay. Hopefully we're all aboard, and we're not all bored, right? And again, if you have questions, feel free to unmute yourself to get my attention. And here's a typed version of what we just experienced. Okay. Ooh. All right. So here we have another formula. So again, if you have your formula sheet, it would be a good idea to update your formula sheet with this guy. Okay. Like in the chat, real quick, like in the chat in Zoom, I'm going to describe something again, like just in the chat, can you like just type or feel free to unmute yourself what I'm describing, right? So if I had 7 numbers, I add up those 7 numbers and I divide by 7, what did I just find for those 7 numbers? All right, let me say that one more time. And you can type your response in either in the chat or feel free to unmute yourself. I see mean, right? Yes, that's correct. Either the mean or the average, right? Average, right? So, you know, if we have 5 numbers, we add them up and divide by 5, we're finding the average or the mean. So that's how I remember the midpoint formula, right? It says the coordinates of the midpoint, m of x and y of the line segment joining P and Q are given by this, right? So this formula is basically the average of our x's, comma, average of our y's, right? We have 2 things added up divided by 2. Same thing here. So average of the x's, comma, average of the y's is how I remember the midpoint formula. Okay.
Can you find this on the Pearson thing? Because this is a Pearson textbook, isn't it?
This is Pearson.
Okay.
Say when you find this, you mean the lecture?
Yeah. Well, not the not the lecture, not the lecture. I'm talking about like I didn't finish the course of the last slide. I'm saying like to go back later. Is it like
oh yeah. So to find this, you're gonna find it in Blackboard. So if you go to Blackboard and the second item that says box link, that's where I'm gonna load this as soon as we finish. So if we open up this main folder, as soon as we finish class, I'll load a PDF of all the stuff that you see. And so the item number 2, it says daily PowerPoint lecture slides, box link. That's where you're gonna find a copy of this lecture. So and I load it pretty much at the end of each meeting.
okay?
Okay. So again, if you have your formula sheet, again, the way I remember midpoint formula, average of the x's, comma, average of the y's. For distance formula, I know that the distance formula comes out of the Pythagorean theorem. And so as long as you can kind of like get a sense of creating the right triangle from the ordered pair, identifying your legs and the hypotenuse, then, you know, and how to find those distances. Okay. So then here, we're asked to find the midpoint of the line segment joining these 2 points. We have just under 10 minutes remaining, so we're just going to kind of power through. Again, every time we use a formula, the recommendation is to write it down. So since we're using the midpoint formula, midpoint average of our x's is going to be x1 plus x2 over 2, comma, y1 plus y2 over 2. Okay. Also, what I like to do whenever I get an ordered pair, I personally just like to label it off the rip. x1, y1, x2, y2. Okay. So then the next thing I like to do, if I'm going to do substitution, is replace my coordinates or my components with blank sets of parentheses, right? So the midpoint between P and Q, something like that, is going to be, so we got our x1 plus x2 over 2, plus, not plus, comma, y1 plus y2 over 2. Okay. So then we're going to do our substitutions. Our x1 is -3. Our x2 is 1. Our y1 is 6. Our y2 is 4. Right. So we were fortunate in this example in that, we don't have a lot of crazy things going on with the sign. So we didn't really need the extra parentheses in this case. -3 plus 1 is going to be a -2 over 2. 6 plus 4 is 10 over 2. So then it looks like it becomes -1, 5. So the coordinates of the midpoint, if we were to plot the two original given points with this midpoint, you'll see that this point is going to be halfway between the line segment joining points P and point Q. So this was us doing this example by hand. Here is a typed version of what we just experienced. Okay. Let me see. I think we got time for at least one or maybe two more examples. So then we have this definition. We have that an ordered pair A comma B is said to satisfy an equation with variables A and B if, when A is substituted for X and B is substituted for Y in the equation, the resulting statement is true. An ordered pair that satisfies an equation is called the solution to the equation, right? So we say an ordered pair is a solution if we plug in X for the first, if we plug the first component in for X, the second component in for Y, and if it results in a true statement, that ordered pair is a solution to the equation, right? If it results in a false statement, then it's not a solution. Okay? And then frequently the number of values of the variable Y, frequently the numerical values of the variable Y can be determined by assigning appropriate values to the variable X. For this reason, Y is sometimes referred to as a dependent variable and X as an independent variable. So like, for instance, when we go to start looking at graphs of equations, the first way that we have to graph an equation is by making a table and plotting points, right? And so when we go to make a table, we're going to choose just values of X. So we kind of just choose the values of X. We pass these independent variables through our function, and on the other side, it's going to spit out our dependent variable, our range or whatever. And so, the first way that we have to graph these, we basically generate this list of ordered pairs. We plot the points, and then we either connect them with a straight edge or connect them with a smooth curve, right? So the graph of an equation in two variables such as X and Y is going to be the set of all ordered pairs A, B in the coordinate plane that satisfy the equation, right? So these graphs that we are going to be looking at are going to be pictorial representation of the solutions of the equations, right? So what that means is that if given a graph of an equation, we can choose any ordered pair on that graph. If we plug it into the equation, it's going to make it true, right? So then in this example, we're asked to sketch the graph by plotting points. I think I'm kind of burnt. So sketch the graph of this. So with these X values, right, we just chose these X values. And then you take each X value, pass them through the equation, and you're going to generate a corresponding Y values. So then we have this set of ordered pairs. Then what we're going to do is plot the ordered pairs and connect them with a smooth curve or a straight edge. And that'll be our graph of the equation. I think I'm going to leave this as an exercise. There is a digital version of this on the next slide. But I think I'd rather leave this as an exercise for you. Did you guys have any burning questions for me? Let me go ahead and make a copy of this available. I think that's correct. I think I got them all in the same location. 23, traditional, this one, notes, updated data. That's fine. Okay. So when this bar finishes loading, you'll receive a copy of anything that you saw me writing. If there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your evening. I'll see you all on Wednesday, same time, same place. Peace, guys. Yes. Take care. Yep. Check the chat really quick.